Thank you very much. I appreciate the invitation to come and speak to your group. I apologize for not having accepted the invitation earlier, but I do a huge amount of travel, and it's hard for me to surrender my passport for 2 or 3 weeks to get a visa. Luckily, because of the Olympics, I didn't have to get a visa, so I took the opportunity to come. And of course, I deserve it because my country is completely rude for people who are trying to come there. So I accept that's part of the way it all works. This is my second time to Brazil, my second time to your city. The first time I came down, my youngest daughter was going to the university here. So came down to visit her after almost a year of school here. So it is wonderful to be back and feels very, very comfortable. So I want to talk today about Oracle database installation. And I'll explain a bit more about why both of my topics today look like they are very basic, easy topics, but why, in fact, there are issues that exist where we need to be paying attention. This presentation was done for all of the user groups on the Latin America tour for OTN. So it's actually a presentation designed for twice as long as we have today. So there will be parts of this that I will skip, but I'm leaving you with a copy of the slides for your user group so that you can go through them and use them as guidance. So I'm going to be hitting the most important points so that I can finish on time for those of you who are here. And I notice many of you are not wearing the translation headphones. So if you have an issue with my English, have a hard time following, please let me know. I will go back and cover those things. I'm going to skip very quickly over the introduction slides. They're more there for the presentation that I'm giving to your user group. I think hopefully everyone has a rough idea of who I am. So my website and some of the things that I do as part of my consulting practice in the United States. Very excited, not about database as a service, but about some of the new cloud offerings that Oracle will be announcing at Open World. And for everything that you've heard about the Oracle Cloud, and as wonderful as it is today, it is going to get substantially better and much more exciting come Open World of this year, because one of the things that you will find when we talk about the Oracle Cloud today is we wonder as DBAs, what's my job? If we move to the cloud, what do I do for a living? How do I do my job if Oracle's doing it? When you hear the announcements coming out of Open World this year, you are going to see that the Oracle Cloud has been changed to make DBAs more important and more critical. So it'll be very exciting. Be sure you watch this year at Open World. I've been coming to Latin America for OTN now since 2009. 2010 was my first time in Lima at the conference. Tim Gorman, who's here with me, and Jonathan Lewis, we were in Beijing in 2013. And a couple of years ago, went to the Galapagos Islands in Ecuador and found out that park benches were not made for people. So going to be a lot of material here. And again, I will be skipping through some of the slides to sort of focus on the things that are most important and most critical. What I want you to understand coming into this is that since I first got involved with Oracle, which was version 5, version 6, Oracle has changed tremendously. What worked best in Oracle 7 will still work today, but it won't work very well. And the vast majority of what I see when I go to customers and when I do consulting is that people are still primarily running Oracle databases as Oracle 7. If you learned Oracle 7.3.4, you can pretty much do Oracle 11.204. And you don't have to change very much of what you do. except that if you change, what you deploy will be substantially better. So I'm talking about installation because, quite frankly, the Oracle installation of the Oracle database is not very good. Most of the problems that people have with Oracle database installations, which are not very stable, they keep having to fix things, they are not very secure, people can break in. I can usually break into most Oracle databases in under 20 minutes. I have done a lot of security work, and usually 20 minutes is all it takes me to own someone's database. And performance. We have, as a matter of scalability and performance, the fact that most of our time as DBAs, our biggest problems are tuning problems. And a lot of that is due to the way Oracle installs itself. So I want to talk about the fact that it's not just about your application. It's not just about SQL. It's about everything from silicon up that affects the performance. And when we don't get it right, we don't get to go home at night. We have to work weekends. We don't get the quality of our lives because we're spending so much time trying to fight that initial installation of the Oracle database. So the biggest single difference between installing with Oracle Universal Installer and Oracle DBCA, the Database Configuration Assistant, is that they will install it and it will run, but it will not run particularly well. One of the things that we have seen as we've worked our way through installing Oracle, and when I started off doing Oracle, I remember doing my first Oracle installation. There was a team of us. There were 3 or 4 of us on the team. It took us 30 days to do one database installation because we would install, things wouldn't compile, we would get it wrong, we'd have to take it all down, reinstall, we'd have to call up Oracle support. It was difficult to install an Oracle database. Back then, we got awards when we could do it in 30 days. Now, if you can't do it in 30 minutes, there's something wrong. But we've lost a lot of technique by using DBCA and just trusting that Oracle does it right. And by default, Oracle does not do it right. It does it adequately, but not particularly well. So one of the things we want to look at is some of the things that will allow us to do a better installation so we spend less time trying to fix things after the fact. One of the things that's critically important in terms of getting it right is to install the Oracle client software when you install the database. When you just install the database and you give DBAs the ability to go in and do their work using the SQL Plus that's in the Oracle home, you have no security. It's as simple as that. Because now everybody who can SU to Oracle gets access to the entire file system. And when you can get access to the file system, you can compromise any file. You can read every diagnostic trace. You can run everything. You can do anything you want to because you own the file system and you own the Oracle database. If you use a different user and you install the Oracle client, DBAs can still log on and can still do everything they want to do. But by denying access to the file system, you increase your security very, very substantially. And you decrease the ability of a lot of people who don't belong in your databases to do what I do, which is to break into databases and steal data. So let's talk about some of the basics. First of all, before you install a database, you need to understand what it's going to be used for, because different installations require different configurations. You do it wrong, and you pretty much are doomed to be fighting it the entire time that you're going there. Understanding the service level, recovery points, your recovery times, critical to getting that initial installation correct. I'm going to skip through some of these things in here right now, but I want to point out, as I said, some of the more critical pieces. One of them is that we generally allow network administrators to define our networks. And when we do, particularly when we get into data guard, particularly when we get into replication, particularly when we get into rack, they almost inevitably will get it wrong. Here's the number of networks it actually takes to do a proper installation of an Oracle database. There's the lights out card, or the ILOM. I need a network, an IP address for that. I need IP addresses, and usually at least 2 of them for redundancy in order to have my application connect to my database. If I have a SAN, I need fiber channel connections. If I have NAS storage or Oracle ZFS, I need connections there, separate network. If I'm doing rack, I need to have a UDP with jumbo frames configured, with a lot of very specific configurations, such as not having it be available to public, such as having it not be a keep alive, required for doing that. Preferably separate networks for replication, so I'm not fighting against my public access in order to be able to do backups, in order to be able to do replication. So a lot of networks that are required to get it right. We can also greatly improve performance by getting network interface cards that offload the work from the CPU that is running the database to the network card. Let me give you an example of what's going on right now. When you buy licenses from Oracle, you pay by CPU core. If that CPU core is doing your storage, and that CPU core is doing your TCP/IP, and that CPU core is also running the database, you're paying Larry Ellison and you're paying Oracle for CPU that isn't really available for doing computing. It's doing I/O. But yet you pay the same thousands of dollars per core for that license. If you, as a DBA, get involved in picking the hardware and talking about network interface cards, you can get cards like this, where the network interface card has CPU on it. And that CPU is used for your communications, so that you have to buy fewer Oracle licenses to do your work. From a storage standpoint, there are lots of things we can do. I'm going to skip over that right now, but I do want to get into some of the configurations that I see a lot and the issues that they create. One of them has to do with virtual environments. How many of you are using VMware with your databases? Hopefully you know that Oracle does not like to support VMware. And Oracle will tell you that if you have a configuration problem, if you have a problem with a service request, that they can just tell you to repeat that on bare metal, and if you are successful on bare metal, they will help you. And by successful, meaning you can reproduce the problem. Now, most of the time, Oracle doesn't enforce that, but they can. The bigger issue is on licensing, because a lot of people are using VMware as a way of restricting their licensing, or at least they assume they are. So they buy licenses for Oracle database, and then maybe they need advanced security or compression or rack, and they think that by using VMware, they can buy a smaller number of licenses by putting the database into a VMware container. I don't know how carefully Oracle enforces it in your country, but in the United States, when Oracle hears that somebody has VMware, they send in the license police, and they go looking for a really, really big check, because Oracle does not recognize VMware at all for licensing purposes. So you can't minimize the number of CPU cores on a server and say we're only licensing what's in the VMware container. Here's the way Oracle licensing works. If you have the right slide and you press the right button, you will find that all containers are either what they call hard partitioned or soft partitioned. If it's hard partitioned, meaning you can't vary the number of CPUs within the container, it's a fixed number, Oracle will recognize it for license purposes. And you can see that most of the different container technologies, whether it's IBM, whether it's Oracle's, most of them are hard partitioned, which means that Oracle will respect the container for licensing purposes. Unfortunately, for VMware, it's always soft partitioned, which means that Oracle does not respect the container and will expect you to license everything on the entire server. So be aware of that as you go forward. And one of the things we tell people in the US is that friends do not let friends use VMware in production. There's very good reasons for that. Other things that we talk about when we talk about optimizing our operating system configuration for Oracle. One of the most critical ones is NUMA and swappiness. By default, Oracle gets both of these wrong 100% of the time, except if you buy an Exadata. If you buy an Exadata or a supercluster, then they get it right. How many of you are using huge pages with your Oracle configuration? It should be 100% of you. You will get substantial improvements in performance by configuring huge pages. So I have some information in here about that. Go through these slides, go through the Oracle docs, talk to your system administrators. You want to configure huge pages. You'll spend far less of your CPU resources swapping memory pages back and forth. And the larger the database, the more critical it becomes. So I've got the calculations in here for doing that. The other thing that you want to be aware of, how many of you are in Oracle 11? 11.2? Most of you are in 11.2. Oracle 11, by default, when you install it, gets memory management wrong. Oracle Memory Management in 10.2, which was ASMM, is the best way to do it. When Oracle went to 11, they went to something called AMM, which was horrible. And Oracle has realized that it was not right. And once you go into Oracle 12, they go back to the 10G memory management model. So they've admitted the memory management in 11 was not done particularly well. One of the things you will absolutely want to do is get rid of AMM and go back to Oracle's ASMM model, because it will cause a lot less locking. You will get better performance and have fewer memory faults when you do it. Another place where we almost inevitably get Oracle wrong is in setting up DNS caching and setting up resolve.conf, where we are referring connections to a DNS server. One of the things that happens is that by default, when you try to make a connection to an Oracle database, you're trying to connect to production1.oracle.com. You're trying to connect by a name. You're not saying connect to 192.168.17.4. That's the job of your DNS server. If you have resolve.conf set up correctly, it will avoid faults. If you enable this particular configuration file, which by default is not on Linux servers or other servers, then your database server will cache that information and can do the translations without having to go to DNS, which speeds up connections. To give you an example, by default, this is what you're going to see. Lots and lots of zeros. Once you configure DNS properly on your server, you'll notice here, this was on a real production server. We said, let's go ahead and enable caching for 60 seconds. We got a cache hit ratio of 70.2%. 70.2% of the time when people were trying to connect to the database, instead of having to go to DNS to resolve the name, the server was able to make an instantaneous connection without the extra overhead. Another piece of resolve.conf that is not going to work very well in almost every situation is this is very typical of what I see. This is 3 DNS servers when we are trying to resolve names into IP addresses. What I almost never see when I go to production companies running Oracle, and I'm talking the biggest telecommunication companies in the world, is that the system administrators have not used all of the options. So it doesn't talk about the number of attempts. It doesn't rotate between the different DNS servers. It doesn't do a timeout. If you don't do that and you have a DNS failure, you are more likely to have problems connecting to an Oracle database. Now, skip over some of these things around UDP. I want to talk about NUMA. How many of you have heard of NUMA? This is absolutely typical of every Oracle audience I have ever spoken to. Except on Exadata, Oracle configures NUMA incorrectly 100% of the time. Because the Oracle installation assumes that your system administrator read the Oracle documents and said, I will disable NUMA on the server. The reality is that system administrators have never read the Oracle docs, are not going to disable NUMA, and therefore your server is configured for NUMA, but your database is not. Here's what NUMA is. If you have more than one chip, more than one socket, each of those sockets, when it plugs into your motherboard, has its own processors or its own cores and its own local memory. So each chip is associated with local memory, and if it needs to allocate memory and doesn't understand what it's doing, it might allocate memory over here. And in fact, this happens a lot of the time and leads to a lot of performance and memory allocation issues. Essentially, NUMA means if I'm doing my work on this on a core, on this socket, then I should be talking to this memory. That's the way every Solaris box and essentially every Linux box is configured. If you want to find out whether your hardware is configured for NUMA, you run a Linux command called NUMA control. And this is not a comment. Neither is that a comment. This is actually the command. It's NUMA control -- show or -- hardware. If NUMA is configured, you will see multiple memory pools. So for example, that is CPU socket number 1. That's the second one. So I have 2 chips. I have 24 cores. And you'll notice that my CPU, some of it is bound to one of the CPU core sockets, one of them is bound to the other. That is proof that NUMA is configured on the machine. Here's another one with 48 CPUs. I think, yeah, this was on an Oracle ODA. That's what it will look like. You will see here, this is not NUMA. There is only one node. Here, this is with NUMA. The Oracle database by default does not recognize NUMA. You have to do an alter system, set enable NUMA support in order to get the database to understand NUMA. If you're seeing memory allocation issues or slow memory allocation, it's very likely that you can solve the problem in a matter of 1 to 2 minutes just by changing your database to match your hardware. And this is also true if you're using VMware. If you look at the VMware documentation on how to run VMware on NUMA machines, what you will find is that your VMware container also has a configuration that allows you to tie the container to one socket or both sockets and to recognize NUMA architecture. I have almost never seen a VMware installation where NUMA was properly configured. The other important one is what we call swappiness, and that is, does the operating system swap pages out of memory when it doesn't really need to? By default, Linux, and that means Red Hat Linux, Oracle Linux, do a lot more swapping than necessary. So if you're finding that when you're running top or you're looking at your other Linux configurations, that you're doing a lot of page swapping, but yet there's still plenty of memory, most likely it's due to the fact that the default value for swappiness is set at 60, meaning it will swap pretty aggressively. It will swap when it thinks it might potentially someday run out of memory, as opposed to waiting until it really needs the memory. On Oracle systems like Exadata or ODA, the engineered systems, Oracle has played with this and does not use that 60 number. For swappiness, which is the default, they actually change that on their engineered systems to improve performance. I normally change it to about 30 to 35 so that I am still swapping before I run out of memory, but I'm waiting until I really know that I'm going to need the memory to do it. So lots of other things here around Etsy host, Etsy profile, and again, a lot of things here that you will want to go through and look at and compare with your systems, and things that will help improve the performance. A lot of these things that I've highlighted here, like this one, are misconfigured most of the time when I look at Oracle database installations, and especially when there's more than one database running in the same container or running in the same operating system. If you are not familiar with the concept of STIGs, Security Technical Implementation Guide, this is something that you can use. And when I was in Beijing, China, we had a big talk about how to secure Oracle databases, because of course they were afraid that the US was breaking into their databases. And I said, well, of course we are. And you're breaking into ours, and the Russians are breaking into everybody's. So it's just the world that we live in. Everybody's breaking into everything. But what's interesting is that Oracle support has produced a script that you can use to lock down Linux servers. And these are called Security Technical Implementation Guidelines. They're actually from the US Department of Defense and the CIA. And you can download the script for free from Oracle support, and you can run the script, and it will tell you what all the weaknesses are in your Linux installation, and you can fix them. Now, there is a bad part of this, and the bad part of this is that there is a fix option. It corrects the violations. Do not run the fix. Here's why. Because from the US government standpoint, a USB port is a security violation. Now, if you have a USB keyboard, that means your keyboard gets locked out. So you don't want to run the script and say, go fix all my security violations, because now you will have a Linux box that you can no longer connect to. What you want to do is you want to run the check option. This will list all the violations, and then you and your system administrator can figure out which ones to fix and which ones not to fix. So it comes in 3 levels of violations, and here's a pretty typical group of the most important ones, such as it found that real VNC was installed. That would be a violation. There was no password for GUOB. Here, of course, it said, wait a second, the USB ports are working. That's a security violation. That's the one you don't want to have it fix, or you'll lock out. Then there's security 2 violations, security level 3 violations, less and less important. One of the things that this will catch, for example, is that by default, Red Hat Linux, Oracle Linux, all the different Linux versions install a username games. I don't think anybody needs a username games on a production Oracle database server. I think you will agree. So let me skip through some other pieces of the puzzle here. Another place that Oracle inevitably gets installation wrong is in creating redo logs. If you just run OUI, DBCA, you will find that you are not getting a good, solid configuration for usually control files and for redo logs. If you use the normal default, you will usually end up with one control file. If that control file becomes corrupt, you'd better have a backup, which means you're probably going to RMAN or going to tape to try to find the control file. The same thing with redo logs. They need to be multiplexed. You need to have at least 2 separate copies. Now, in control files, I would say create 2 control files, put them on separate physical disk, separate stripes, separate ASM disk groups. That way, if you lose one, the database keeps running. With redo logs, you want to have 2 members. You want to have at least 3 redo log groups. You want to have at least 2 members of each group. That way, if you lose one, if one becomes corrupt, if somebody accidentally deletes one, you still have a running Oracle database. By default, it does not do that. So in a typical situation, I'm going to say, let's go and look at the redo logs. And this is one that was a default Oracle installation of version 12. It created 3 redo groups, but only 1 member. We went in and did an altered database and added 3 more files, a second member for each one of our groups. You'll notice that these were put into a different physical directory so that now 3 of our redo logs are in the fast recovery area, 3 are in another directory, different file systems, and we're safer. That's something that will not only improve performance, but also will save you from some pretty substantial outages. Another piece of the puzzle you'll see is that Oracle will often missize the redo logs. You ideally want to be doing a redo log switch every 5 to 15 minutes. So this installation here is pretty good. I should be seeing somewhere between 4 and 12 redo switches per hour. And I've got the source code here for creating this particular report. You'll notice that clearly there was something big going on right there. You'll also notice that a lot of redo is generated at 6 o'clock in the evening compared to 5 o'clock, compared to 7 o'clock. You see the same pattern at midnight. You see the same pattern at some other times where there's a big jump in the amount of work that's taking place. One of the things that we see is that very often human beings think that nobody's working at noon because everybody goes out to lunch, so they schedule a huge amount of work for noon. Or they say, well, everybody goes home at 5 o'clock or 6 o'clock, so we can run this big job at 8 o'clock. And everybody does all their jobs at the same time, and we end up putting far too much load on the system. So one of the things you want to look at is making sure your redo logs are configured to the right size, but also looking at the patterns of redo log switches to make sure that you are spreading your jobs out over periods of time when there is a lower amount of work being performed. Listener configurations. By default, every Oracle installation is insecure. Oracle's tools for doing installation have never configured a listener correctly in the entire history of the Oracle company. And that's not Oracle's fault, because Oracle doesn't know what you have. They expect you to read the documentation and to understand the things that you need to add in. So there is a Net Services Administrator's Guide. I encourage you to read that and to look at all of the options that are there and to implement a lot of them. One of them, for example, Session Data Unit. By default, when Oracle is sending information from the server to a client, server to application server, it is using a very, very small packet as compared to what your network can do. You're making far more round trips than are necessary. This severely impacts performance. So looking at Session Data Unit and configuring that into your listener.aura or SQLnet.aura or TNSnames.aura, depending on where it's appropriate to do it, can give you, again, a substantial improvement in throughput and in performance. So, for example, in a SQLnet.aura, I might do something like this. Default SDU size, and say I've got a Cisco switch. I've got a Juniper switch. I've got 10 gig Ethernet. Why shouldn't I be sending 32K rather than 4K or 8K every time we send a packet? You get substantially better improvement. The other thing that you want to look at from a security standpoint in configuring your listener is allowed logon version. So for example, with this configuration here, you can connect to this My Oracle database if you have SQL Plus version 12. But if you have SQL Plus version 11, it won't let you connect. So I can control to make sure that people with older versions of software cannot connect to my application. I can choose version 11.1, version 11.2. I can make sure that even if they have valid user ID and password, that they have to have a specific version of the tool. Another piece of the puzzle that is, from my perspective, absolutely critical if you want to keep people out of your database who don't belong there is valid node checking. Now, I first saw valid node checking in Oracle in version 8. It's been there for a very, very long time, but it's almost never deployed. And here's what valid node checking does. And again, this goes into SQLnet.Aura. Is what I am saying is you cannot connect to my Oracle database if you're not coming from a valid IP address. So I found when I was working with Oracle security team, 84% of all the data stolen from Oracle databases was done by people who had a valid user ID and a valid password. Think about that. 84% of every row ever stolen from an Oracle database, they had the user ID and they had the password. That's not going to protect your database. And it certainly won't protect it from somebody like me. But this will, and here's why. Because I can list what are called invited nodes. So let's say I have 50 application servers. I can hard code those application servers by IP address. If you're not one of those 50 app servers, you can't get into the database even if you have a valid user ID and password. This is really important. If somebody is hacking, they're not going to be at the IP address of one of your app servers. They're not even going to know what that is. So a DBA can put in their own personal IP address. They can put in the addresses of those things that can connect. And if someone else from a different IP address gets a valid user ID and password, they can't get in. So I can say, if you have a valid one, we'll let you in. If I find that someone is trying to get in from an IP address that I don't want them getting into my database, I can block them out. I can specifically call them out by network or by IP address and say, I don't care if you have a valid user ID and password. You still can't get into my database. So here's some of this stuff also put into a listener.aura. And there's your global dynamic endpoint information. If you are doing replication with Golden Gate or with DataGuard, specifically with DataGuard, you want to modify your listener.aura or your tnsnames.aura to increase the buffer sizes and absolutely increase the SDU so that you don't have performance issues related to your replication. Again, the Oracle installer will not do this by default. It does not know this stuff. Database configuration in general, I'm going to skip through a couple of these things in the interest of time. Security-wise, by default, the Oracle profile can enforce security. It can enforce expiring passwords. It can enforce things like not reusing passwords. By default, Oracle has it disabled. I don't know why. One of the things that you will see if you look at the kernel parameters that are called out and the password parameters that are called out in the profile, what you'll find is that it's totally insecure and that it's disabled. So you want to do things such as changing the reuse of passwords, change the number of failed login attempts before it locks someone out. These are all critically important to keep someone from doing brute force attacks or from using passwords which are not strong enough. As of 12C, the name of the password verify function has been changed now. You will not want to use the old version 11 verify function to validate your passwords and to make sure they are complex enough. The other thing that you will see as you go forward is that in the script that Oracle provides, util password management script, they have now changed that dramatically in version 12. You want to open that script up now and read it. Not only has the password verify function changed, but they have also changed the default profile to allow more secure profiles. So they have one for Center for Internet Control, which is for people like eBay or Amazon.com. It's what they recommend to them for security. You can just uncomment it and configure that. And again, there's also one for the U.S. Department of Defense that they've coded into that file. So open the file, read it, and follow it. It will help a lot. There are a lot of security parameters in the init.aura that you can configure. None of them configured by Oracle by default. But here's one of the most important things that you'll see when you move from Oracle 11 to 12. There is now in RDBMS admin a new file which has never existed before called secconf.sql, which stands for Secure Configuration. This has never existed in an Oracle database before. It's important that you read it and understand what's in there because this is run by default. This is not something where you say, I want a secure configuration, I will run this script. It is a new capability that Oracle has changed the way they secure Oracle databases, and you need to understand what it's going to do to your database that you've never seen before. So secconf.sql, it revokes from public a lot of things that were granted to public in the past. However, in spite of the fact that Oracle has done that, they have still not revoked some of the most critical privileges that they give to people, such as, by default, Oracle gives access to all source to public. Now, I don't know how you feel about this, but I can tell you that from my perspective, every user of my Oracle database does not need access to all the source code for the application that they're running. To me, that is just lunacy, but by default, Oracle gives access to all source to public. You probably want to take that away. And there are lots of other things that you probably want to take away as well. All of these are granted to public. I have no idea why a user of an Oracle database needs to be able to see heat maps. I don't understand why they need to look at histograms or pending statistics. Oracle grants this to public. All of these are security violations that you will want to address. In particular, some of the most dangerous things and things that I will normally live demo, but I'm using the conference laptop right now because we had a little problem with mine. Look at using this particular capability. It is granted to public in every Oracle database by default. Util internet address. I can usually, from inside of most companies, use that to go out to CNN.com or Oracle.com or any IP address I want. In other words, from inside the Oracle database, I can penetrate the firewall and I can talk to the internet. That's not a good idea. All of these capabilities right here that I've got highlighted allow you from inside of an Oracle database using access granted to public to send data from the database out to the internet, which totally compromises security. And I've got just 1 minute left, so I'm just going to very quickly skip through a couple more things here. I've got a demo here showing how this was used. Now, I did this against the University of Minnesota, and you'll notice that when I did it, I was able to go out there and hit parts of their network. I was able to expose SMTP servers, and I was able to expose their identity management servers just by using a tool inside the Oracle database. So lots of things in here that affect your ability to lock down and protect your Oracle databases. I recommend very much that you go through this, you look at the things that I've called out, identify those vulnerabilities, identify some of the misconfigurations around the listener, and next time you do an Oracle database installation, go through, and I'm not saying don't use DVCA, I'm not saying don't do OUI, but as soon as you do it, before you turn that database over to your applications and to your users, go through and fix the configurations around control files, fix the configurations around redo logs, fix the configurations around security. You'll spend a lot less of your life trying to deal with problems inside of your Oracle databases because you got it right in the first place. Thank you very, very much.